To simplify radicals. Remember, a radical is a square root sign. So what we've been doing so far is when we solve like 2x squared equals 10, you'd have to divide by 2, x squared equals 5, square root, and then we rounded it to the nearest tenth for 100. 2.36, which is 2.24, 2.236. Okay? Now, what we're going to be doing now is they're going to say leave it in simplest radical form. What that means is you don't use a calculator, you just leave it as a square root. So instead of writing it as a decimal, you just say x is the square root of 5. And again, it's plus or minus. So instead of putting it as a decimal, you just leave it as a square root. Anytime you see that, leave it in simplest radical form. So today what we're doing is simplifying radicals. Now, some properties of radicals. If you've got the square root of 2 times the square root of 3, as long as they're both under the square root sign, you can just multiply that. Okay? If you're adding or subtracting, it's just like variables. You can't add an x plus a y because they're not like terms. So you can't add or subtract unlike square roots.
So if it was a 2?
If this was a 2, then it's just like this is an x. What's x plus x? 2x. So square root of 2 plus square root of 2 is 2 square roots of 2's. Okay? Now what we're doing for simplifying is, first we're going to be doing the multiplying ones. So we don't need to worry about the adding or subtracting ones now. So you got to remember, if you have this, that's the square root of 20. If there's a number on the outside, it just stays there. If there was a number here on the outside, you'd multiply those, and you'd multiply those, but it stays under the square root. Okay? If there's a fraction in a square root of 20 over the square root of 30. You could just simplify that as 1, since they're both under a square root. You could do it like that. And then you could simplify this. 20 over 30 is 2/3. So if they're both multiplied, you can just multiply and put it under 1. If they're both a fraction, which means divided, you can just put 1 sign and then simplify it. Okay? Now this works the other way. Is if I had the square root of 20, I could split that up to say square root of 4 times the square root of 5. Exactly the same thing. Or square root of 10 times the square root of 2. That's the only 2 I could do, right? Yeah. Square root of 32, I could go 4 times 8. 16 times 2. I think those are the only ones to get 32, right? Yeah? This is what you're going to be doing to simplify. In order to simplify radicals, no perfect squares can go into it. If no perfect squares can go into it, it's considered simplified. Like the one we had before when I showed you, x was plus or minus square root of 5. The perfect squares are 1, which we don't use in this. Square root of 4 is 2. We went through these already, didn't we? You guys all know the perfect squares? 5 times 5, 6 times 6, and so on.
I see it.
Here's the first 10, which are easy to remember. A lot of times they just deal with oops, the first 12. Again, you can use a calculator if you forget what they are. So what this means is if you look at the radical, will any of these numbers, remember it's the perfect squares, do any of these go into 5? No, so it's simplified. If you had the square root of 20, do any of these go into 20? Which one? 4. You always want to pick one of these numbers. Square root of 4 times the square root of 5. So now is the simplifying part. What is the square root of 4? So the answer is 2 square roots of 5. They're the exact same value. If you punch this in the calculator and this in, you get the same decimal. It's just this is considered simplified, this is not. So remember I showed you we could have did 2 times 10 makes 20, but that doesn't help us at all because square root of 2 isn't a perfect square and neither is square root of 10. So that's why that doesn't help you simplify it. Here, both of them would work because 4 is a perfect square, right? So this turns to 2 square roots of 8, but this one also works. Square root of 16 is 4 square roots of 2.
So you don't simplify the other one?
Well, these are the same answers if you punch them in the calculator. It's just this is not simplified. Because what perfect square goes into 8? 4. So that can break down again like that. And then the 2 is still in front. Square root of 4 is 2. 2 times 2 is 4 square roots of 2. So it's quicker if you find the biggest perfect square that goes into it. If you don't, then you got to simplify it again. So what you're going to want to do, if you got a bigger number, like 80, 4 does go into it, but you should check to see if something bigger does. A good idea is with your calculator, start about halfway. 49 is over half, so 36. You know 36 doesn't go into it, neither does 25. Check to see if 16 does.
Oh, never mind.
16 does go into 80. 80 divided by 16 is 5. So I found the biggest perfect square, so that makes 4 square roots of 5. Okay?
What's my 2 square roots of 5?
No, because the square root of 16 is 4. I'm glad you brought that up because a lot of times people make that mistake. They see this as a 4 and then they square root it again. Remember, once you square root something, it's no longer square root, it's just a plain old 4. Okay? Sometimes people will do this. The square root of 64 is 8. No, not that one. Usually it's the 16. They'll say the square root of 16 is 4, but then they think, well, that's a perfect square too, so then they write it as 2. But remember, once you do that, it's done. That's the answer. 256 is the other one a lot of people mess up. That's 16, and then they say, well, that's a perfect square, so they write it as 4. They say, well, that's a perfect square, so then they write it as 2. It's just that. Okay? If there's a bigger number, it takes a little bit longer. 144 is about halfway. That doesn't go into it. So you can check 121. If you divide them, that doesn't. I know 100 doesn't. 81, go 320 divided by 81. Oops. Nope, get a decimal, so check 64. Yes. 64 times 5. So that makes 8 square roots of 5. Okay?
So you take like square root and then
Yep. So when you rewrite these, you always want to put the perfect square first because that's going to turn into just a whole number. And then the other one won't simplify any further, so that just comes second. It's really not wrong if you switch the order, it's just easier to write it this way. Instead of square root of 5 times 8. 8 square roots of 5 is easier to say, easier to write. Now there's a few more simplifying ones. Let's see if that's all we're doing. Yeah, we'll just do these types today. I got to show you some with the fractions though. So, just a few more of these. Square root of 27. What perfect square goes into it? 9 times 3. So it makes 3 square roots of 3. Here's the fraction ones. I didn't show you over there. First of all, look to see, will this reduce 5/16? No. So what you do is you just split it up. Now, can you simplify anything?
Yeah, 16.
That's it. There is one other rule, which we'll be doing these tomorrow. Something is not considered simplified if you have a square root on the bottom, which it turns out this one doesn't. None of them today will. Tomorrow there will be some, so we gotta fix it. Here, this will simplify. We can divide them both by 3. So divide that by 3 and you get 16. Divide that by 3 and you get 25. So square root of 16 over the square root of 25 is 4/5. Yep, they're both perfect squares. So that's what we're doing today, is these and these. Okay? So what perfect square goes into this? 4 times 3, which would make 2 square roots of 3. 63. 9 times 7. 3 square roots of 7. Here, nothing will simplify, so you just separate them, and then you can see it a little easier.
6.
So it's square root of 13 over 6. We should check, does any perfect squares go into that? No. This one, I wouldn't want to simplify simply because that is a perfect square. Well, let's see, we might wait with these. Yeah, let's wait. We're going to do these types tomorrow, so we'll stop right there.